So n into x power, you subtract a 1 like this. What if d by dx of, let's say, 1 by x?
It will be minus 1x, minus 1, minus 1.
X power minus
1 minus 1.
See, it's minus 1 minus 1.
Yeah.
Exponent was negative 1, right?
Yeah.
Which came here, correct? So minus 1 will be
Plus 1. Minus 2.
minus 2. So like this. This is the answer. So when it comes to trigonometry, there are certain formulas. D by dx of sin x is equal to cos x. D by dx of cos x is equal to minus sin x. They flipped. Sin becomes cos, cos becomes sin. It's just that for cos it will be negative.
Okay.
Tan x will be secant square x. Okay. Sometimes, let's say, they ask, what is the d by dx of 2x square, like this? Instead of x square, this is, let's say, twice x square. How to do these types of question?
4x minus 4x 2 minus 1.
See, what we need to first observe is, with respect to what? D by d x, right? The earlier question also, and in the here the main formula is d by dx of x power n will be like this. But in this question, this was x, not 2x, correct? So these two are not matching. So this is called, how to solve this question is to use chain rule command. The name is called chain rule. The process is, it's like d by d of 2x, like this, and then like this. See, these two will get eliminated, but it's that we are introducing them. So you deal this first two, and then you deal this last two.
Okay, so d by dx and 2x square.
Yeah, let's say
what are the
dx.
In this? What is the difference between this part and this part?
In this part, the first part, d by dx, right? This x of x power n.
Okay.
But in this question, d by dx, but this is not x. This is not x.
Okay, got it. Yeah.
They are different.
Yeah, okay.
So make them same, like this. So now that you have written this on the top bottom, write this on the top side. So it's like this. Du by dx can be written as du by dv times dv by dx.
Du by d.
So instead of doing with x, with respect to x, introduce another one, v.
Oh, okay.
See, if you look carefully, it's like the same thing. Du by dx only. It's just that it is a smart trick to introduce this v and then pair up with another one. So
answer will be x?
Answer will be like this. Okay. So let's discuss that. So this into this. Answer will be this into this. So d by dx of d by d2x of 2x square multiplied by d by dx of 2x.
X will be cancelled out.
So these two are same things, right? It's like x square only. It's like d by dv of v square only.
Okay.
And 2x means this constant comes out. 2 into d by dx of x.
Oh.
Constant.
What about the power?
Power? Which power?
We don't need to do 1 minus 1 and all.
Yeah, here we have to do that.
Okay.
So we haven't done yet. We are about to do that. So it's like, what is the differentiation? This one?
2v 2 minus 1.
Or 2v, same thing. So 2v into d by dx of x means 1.
1.
It's like x power 1. 1 into x power 1 minus 1. 1 into 1. So only 2 is left on the this. So 2 into 2 means 4 into v. V was how much?
2x.
2x. So 8x, like this. This is the answer. One alternative method is, for this question speaking specifically, question was about 2x ka square, right? So if you take out, I told you we can take out the numbers. So 2 ka power 2. So 2 square you can take out like this. First you can write like this, 2 square x square, and out. So 2 square comes out 4 into d by dx of x square. It will be
4 bracket d by dx 2x minus 2 minus 1.
2 minus 1 is 1. So 8x. Same answer. So constants come out basically. Okay, so let's talk about that further. So d by dx of, let's say, u can also be represented as u dash, derivative of u. Symbol, just symbol. Okay. So it's like when you are adding two functions, u plus v, combined derivative can be written as u dash plus v dash.
Okay.
Minus means also minus. This is called sum rule, SUN, sum or subtraction.
Okay.
But for product, it's a bit different. So let's say u into v. Differentiation means there is a pattern which is u into v dash plus v into u dash.
Okay.
You pick one number and then take the derivative of rest.
And you pick the other number and derivative.
Yeah. Let's say u v w dash. It will be like u dash v w.
P dash uw and w dash ue.
W dash u v. Like this.
Yep.
So this is called product rule. And there is one more thing which is left is division. U by v ka dash. So it's a bit different from the rest. So denominator into numerator differentiation. Vu dash minus uv dash upon denominator square. Like this. So it's like if they give, find the derivative of d by dx of 5x cube plus 2x square upon 3x plus 1. Yeah. 9x plus 3 or something like that. So what is u and what is v here?
U will be 5x cube plus 2x square.
V will be
9x plus 3.
Yeah, denominator and numerator. So first, how to write this is, can you guess?
9x plus 3 into 5x cube plus 2x2 derivative. What it says?
Derivative.
Derivative. Okay, derivative.
Okay.
When the derivative of the
Minus.
minus 5x cube plus 2x square derivative. Oh no, not that derivative. 9x plus 3 derivative.
Derivative of 9x plus 3. Yeah.
Divided by 9
Divided by
plus 3 square.
denominator का square. Okay.
Hmm.
So now try to simplify. How much is the derivative value?
We have to product.
See, derivative of this number only.
Mhm.
This is not under the influence of derivative. There is no dash
Okay.
for this.
Okay. So we have to take out the constant.
Okay, first it is a addition, right? Two things are added. So you deal with them individually. 5x cube का derivative plus 2x square का derivative.
So the first step is 4x plus 15x square, and in other bracket 9 plus 0.
Okay. Yeah, first one is
4x plus 15x square. And the second will be 9 plus 0.
See, if you take one derivative, do not disturb the other one.
Oh,
Plus
okay, the rule.
multiplication.
Yeah. Then 2x square plus 5x cube. In other bracket 9 plus 0.
Okay. So we can do like this.
Yeah, multiplications.
So that is the way. So if you are doing one derivative, do not disturb the other. Yeah, that's it, man. So that's about algebra. So let's talk about trigonometry. Okay, I think I've given you formulas: sin x, cos x, tan x, derivatives.
When?
Just now, like previously. Here, scroll up. This.
Oh yeah, this for the derivatives, right?
This is.
Right. Hmm.
Okay. So these are important to remember. So whatever we discussed in this so far are important. Okay.
This is the first part of it, right?
Yeah. Differentiation. So that will be useful to solve limits questions.
Limits.
Do you remember how do we solve for these two? These two types. Scroll up. In 7 indeterminate forms. 0 by 0.
I have to go through the notes.
So basically what happens is numerator by denominator. Ka differentiation is what we are doing for these two forms. So for this one, what do we do is this comes here and then this is subtracted by 1.
Yeah.
And then this was all in e power. Whatever the answer you get from here, you do e power that answer. Only 3. Out of these 3, these two follow the same concept. Numerator denominator upon denominator derivative. Numerator derivative upon denominator derivative.
Okay.
Okay. And one more thing. Let's say if the question gives, let's say limit x tends to 0, 5x cube plus 2x square upon 9x plus 11x 1x square, like this.
So it will be 0.
Form will be what?
You have to put the value of x, right?
Yeah. What happens?
0.
So form check is done, 0 by 0. That means what we can do?
Means?
See, form check, we do it because we have to identify whether it is like this or whether it is like this or whether it is like this.
Oh yeah, so it will be the first one.
So it comes under the first two categories. So that means we have to do like this.
Oh, okay.
So what is the derivative of numerator?
Hmm. 15x. The same way, right? We do
Same.
15x square.
Yeah, derivative.
X.
So 15x power
4x.
15x square
Power.
plus
Okay. The square plus 4x. Yep.
upon
9. Do we have to? Okay, so we have to do denominator 2, right? I mean,
denominator also derivative.
27x square plus
27x square plus
2x.
2x. See, now that you have done the derivative, but can you check the form again? X was tending to 0. What happens?
This will be 0 too.
So this will also be in the form of 0 by 0.
Yeah.
So in the second step also, you are getting the form as 0 by 0, correct? That means we have to continue with our process. We have to take derivative of this one again and divided by this one again.
So it will be again 0, right?
Yeah. It's like this form is 0 by 0, right? So treat it as the main question. So 0 by 0 form means numerator denominator upon derivative upon denominator derivative.
Also, we have to find derivative of this form too.
Individually, we have to deal with them again.
Oh, okay. 30x plus 4.
Upon
4. Okay. 7. 54x plus 2.
Okay. Now what happens if you put 0?
It will be 4 by 2.
Okay.
Yeah, 2. Oh.
So this is how we do it. Even if you get in the second step 0 by 0, no need to panic. We have to continue what we have done.
Okay. Got
Same
it.
process. If needed, you have to perform it for the second time, like that.
Until we get the answer.
Until we get some like small answer, number answer, 0 to something 5. So the point of limits is in the question it was 0 by 0 form, right? The answer we get in this was 0 by 0. It is not defined. But then at the end, after solving by using some methods, we get the finite answer. So this is finite. So this is defined answer. This is undefined. That is the point of limits. To get some approximation, finite answer, even though if it appears as infinite. Even though if the answer appears as undefined, our objective is to find the finite approximation. So that is about limits. Okay. So let's go to page number 2. What is an approximate value of 4.99.
4.995.
5, right?
Yeah.
What is the approximation of, let's say, 5.01?
5.
So for a number 5, you can approach it either by approximation from the left, which is 4.99, or from the right, which is
Yep.
5.01. So when it comes to limits, when we say in the question x tends to like this, it means that x is approaching 0. Okay,
Okay.
x is approaching 0. So there are two ways to approach 0, from either from left side or
Wait.
right side. So this is called LHS and left hand limit and right hand limit.
Okay.
LHL we call a left hand limit, RHL
L.
right hand limit, RHL. So basically, for a limit to exist, this is an important point. For a limit to exist, LHL should be equal to RHL. So what do I mean by that is, LHL means 4.99. We say it is 5, right?
Mm.
RHL was 5.01. We say it is also
5.
So these two values are equal. So that means like that. Limit exists. So for a limit to exist, left hand limit and right hand limit should be equal.
Okay.
Left hand limit means, let's say, we represent it like this. X tends to 0, but from the left side, right?
Mm.
So you would write minus. 0 minus means it goes some
Left. Right side.
Left.
Left side. Yeah, left side.
This is LHL representation. Can you guess RHL
Plus?
representation? Yeah. X tends to 0 plus just after 0. So this is about limits. So for a function to limit to exist, LHL equal to RHL. And for a function to be continuous, what? Continuity. Let's talk about continuity. Continuity means, it says, to explain it simply, if you're drawing a graph on x-axis, y-axis, if you're drawing with a pencil, this is called continuous. It's like you're not lifting the pencil at any point in between. But let's say if I draw something like this.
Yeah, it is okay.
You are lifting the pen. See, any graph, even if you draw like this is also continuous because you are not lifting the pen.
Oh, okay.
Simple, right? Continuity means like that. So for a continuity to exist, let's say this is point A. Okay. What is the left hand limit value?
Minus.
Yeah. LHL is equal to limit extends to A minus, right? What is the Y value? Output just before A minus value was this much. Correct? But just after A, what is the value of function?
In plus?
See, it's like see, let's say see the function value, this will be 2, let's say. This will be minus 2. This is minus 2, this is plus 2, okay? The graph is like this. So let's talk about when x is equal to -1. Okay. Just at 1, the function is discontinuous. At -1, at x is equal to -1, graph or function is discontinuous. Any doubt? Discontinuous means you are lifting the pen.
Okay.
First we have drawn like this. Now we have to lift the pen, put here, position here, and then draw like this.
Mhm.
So at x is equal to -1, the function is discontinuous.
Okay.
At x is equal to -1.
Mhm.
So just before -1, LHL will be how much?
Positive one? No, RHS will be
Graph
positive.
value, left approximate value of the graph.
Oh, okay.
This is
Just
the point.
4 minus 1.
Just before -1, somewhere around here, right?
Hmm.
The corresponding graph value is
Minus 2.
+2.
Just before minus 1 plus 2.
Graph ka value,
Oh, okay. Y-axis.
y value is 2. Approximate value of the graph is 2, correct? So LHL, so limit extends to 1 -1 ka minus. Just before -1, let's say this is y is equal to f of x. Its value will be just around 2. Any doubt so far?
Mhm.
But what is happening at -1 only, but this time RHL. What is the graph value?
Minus 1. When you say graph value, that means value of x, value of y?
Value of y. Yeah, approximate value of y. Yeah, y value.
It is minus 2 here.
-2. So just after -1, we get the graph here.
Hmm.
So -2. Oh, what did you notice so far in this 2?
The value changes, the sign.
So LHL, is it equal to RHL?
Hmm.
No, right?
Yeah.
LHL is not equal to RHL. See,
It's not?
plus
Oh, yeah.
-2 difference. So LHL is not equal to RHL. See, earlier we discussed for a function.
In limit, it was equal, right?
Limit exists means LHL should be RHL. If limit doesn't exist, means LHL not equal to RHS.
No.
So that means conclusion we can draw from this is limit does not exist. Okay?
Yeah.
Exist at where exactly?
So it exist at this point.
At this point. Okay? So at x is equal to -1, limit does not exist. Okay? Because LHL is not equal to RHL. So can I also say that if LHL not equal to RHL, function is it continuous?
Yeah. No.
Function
It should, right?
is not continuous. So that is about continuity concept. So for a function to be continuous, what should be the case?
LHL equals to RHL.
That's it. Left hand limit should be equal to right hand limit. Okay? For a function to be continuous, this is the concept we use. Okay? The same as the limit, but this is the main concept for continuity.
Mhm.
Okay? So, yeah. So that's about continuity.
Are these things really useful in CS?
Application of derivatives, maximum and minimum test. See, let's say if there is a function f of x, let's say 3x cube plus 9x square plus 3. Whatever. What is the value of f dash of x?
Derivative.
Hmm.
Again, that thing. 3 into 3.
Yeah.
3 minus. Okay. So it will be 9x squared
Hmm.
plus 18x plus 0.
That's it, right?
Yeah.
So see, the thing is, if f dash of x is 0, okay, we get critical points, the x values. So 9x square plus 18x was f dash of x. If it is 0, what is the value of x? We get
0.
one value of x is 0. Okay. What else?
0. Then what will be the value of x?
Solve for x. This is a question.
It will be 0, right? Because 9 into 0
Yeah.
plus 18 into 0, then it will be 0.
Yeah, that is one value.
Mhm.
एक आंसर. दूसरा आंसर क्या है? See, quadratic, right? This is a quadratic.
Yeah.
I mean, one
So
way
we
to
have
do is factorization, like this 9x into.
we have to solve that equation.
So this is equal to 0 or
2. X plus 2, it will be 2, right?
x plus 2 will be 0. So x is equal to negative 2. Okay. So one value is 0, another value is minus 2.
Oh, yeah. Okay.
So the number which you are multiplying, that will be like equate, you can equate that
Minus
to 0. Okay. Yeah. So these two are called critical points.
Mm-hmm. So what will be the question?
Question will be find maximum or minimum. So this is called first derivative test. We have that one derivative, right? F dash of x is equal to what actually? 9x squared plus 18x. Correct? See, if you take derivative of this derivative, can I write like double dash? This is called second derivative. Okay. So what is the value of second derivative? How much will be?
18x plus 18.
Okay.
X 18 bracket x plus 1. Or 18.
Same thing. X plus 1. So this is second derivative, right? So critical points we obtained was which one earlier?
Critical point 0 is minus 2.
Okay. So critical points 0
Minus
x is equal to minus 2. So what to do is second derivative test means you put this values in f double dash of x in second derivative.
Oh,
F double dash of, let's say, 0, right? Will be how much?
18
Positive or negative?
positive.
So some positive value, okay?
Yeah.
But what about f double dash of, let's say, f double dash of, another one will be
X plus 1 equals to 0.
so you have to plug in the critical points.
Minus 2 plus 1, 1. Minus 2, minus 1.
So overall the answer will be positive or negative?
Negative.
Negative, right? So that means, see, f double dash of something positive means we get the at 0 at x is equal to 0. Okay.
And x equals to -1.
At x is equal to 0, we have maximum. At x is equal to -2, we have minimum.
So minus will be minimum and whatever comes in plus will be maximum.
Yeah, that's it. Okay. So this is about first derivative and second derivative test. Okay, first derivative test means if f dash of x is is positive, function is increasing. If f dash of x is negative, function is decreasing. This is called first derivative test. And that is about second derivative test.
Mm-hmm.
Yeah, I mean, so that's about application of derivative. So there are like minor topics left.